All right, that was the best I could draw that guy. Okay, I was not about to spend too much time drawing him, and the printer at work is not working, so I have to draw these problems. Um, but just FYI, these problems, something I did want to tell you guys, it tells you to find the tension in the cord in terms of weight and theta. So what that means is you know W and theta. Sure, they don't give you a number, but um, I guess what I'm trying to say is like, in the future you might see like, oh snap, you have B reaction, A reaction, W, L, tension right here. I didn't put it there, but tension in that cord. Uh, what do? I don't got any numbers. In this case, you do know W and theta. It could be 5, 10, whatever. In this specific problem, they don't give you a number, but whenever they tell you to find something in terms of something, that means you do know these two things in this case, right? So just like all the other problems, we start with a free body diagram, okay? And let me kind of just explain what's going on. This is the person, right? Person weighs a certain number of pounds, kilograms, whatever, newtons, usually in times gravity, so newtons. Or, I mean, in this problem, they don't tell you, right? But I'm just saying it's either newtons or pounds, pound force. So it's coming straight down. It doesn't matter what way that plank is tilted or this angle is. At the end of the day, weight is always in the negative y direction, okay? On the global coordinate system, you see the y direction here is different, but you'll see what I mean in a second. So the weight is always coming straight down. Look, that reaction, because it's a perpendicular line here. I mean, it's not perpendicular, just along the positive x direction, right? It's not sloped or slanted. It's just a reaction going straight up. Here, since you have that slope here, that reaction is perpendicular to that line. So it's B there, okay? And I didn't put the angles, but you'll see why in a second. I like to keep this one simple, and then you'll see how I break it down. The plank is length L, and this guy is standing right in the middle, so it's L over 2 kind of thing. And it's L over 2 this way, okay? It's not L over 2 this way, because, I mean, it's just obvious, right? The whole thing is length L. He's standing right at the center, and it's L over 2, L over 2. Hopefully you understand that piece. The plank is tilted at an angle phi, okay? So that does not equal theta, different angles. And we need to find the tension in the cord, okay? So look, just by looking at this problem, you probably see solutions online and you're wondering why did they do it that way, right? And I'm here to tell you guys what should be going on through your mind to be solving these problems, okay, for statics. And I had a good professor, thankfully, but I know some of you guys don't. It is what it is, but you gotta learn this stuff on your own. But look, I'm gonna tell you everything that you should know about this chapter, at least for sure. You want to use the summation of forces in the x and y, and then summation of moments about any point to solve your system. Using those equations, and if you can find all your reactions, your system is a statically determinate system, okay? What that means is, it's pretty much what I just said. When you use some of the forces in x, y, and summation about the moments of any point, and if you can find all your reactions using those three, then that means your system is statically determinate. When it's not statically determinate, when it's indeterminate, that means using those three, you cannot find all your reactions. So what do you use? You use the compatibility pretty much. You assume everything deforms equally, and you're not going to know this in this class, but when you get to strength of materials, you will. And you'll realize that everything in the world, like a lot of things, right, are statically indeterminate system. You want indeterminacy because it's redundancy, right? It's kind of hard to explain. Don't worry about it. I don't want to confuse you guys. And let's go back to the problem. But point is, you want a statically indeterminate system. All these problems that you're doing are statically determinate systems. So check it out. In this case, you have weight coming down, A reaction, B tension, length, angle phi, angle cosine, okay? Now, this is the coordinate system that I want, okay? I want this broken up into two components. I want this broken up into two components. The reason I want to do that is because I know W, and if I take a moment about this point, then I can find A, okay? So just like that, I found one of my reactions, okay? Now, I could use, you'll see how I'm going to alter this free body diagram into that. And then once I get that, I'm going to get A in terms of W, right? So just like that, that's going to save me some time. I mean, not some time, but just like help me get the answer kind of thing. And then what I'm going to do is summation of the forces in the x direction on this coordinate, the global coordinates, not this one, the global coordinate system, which is positive y, positive x, right? I want to do some of the forces in the x direction. So I'll have two free body diagrams. I'll have this one, the one you see right now, which is the global coordinate system. And then I'm going to break these two components up, and I'm going to have like a local coordinate system. That's what you call them, okay? The reason I want the local, which is this one, is so I could get a nice A in terms of W, because I want to take a moment about this point, and I don't have to worry about these guys. Because when you take a moment about this point, T is going through it and B is going through it. So at the end of the day, only these two will make a moment, and I don't have to worry about any of this. So just like that, I found A. And then I'm going to do a summation of forces in the x direction. If I do that, T has an x component, right? Assuming positive x is this way in the direction of my blue pencil. So T has an x component, a positive one, and B has a negative one. So just like that, I'm able to find T in terms of B or B in terms of T. And you'll see how it all plays out in the end. But that's the mindset I want you guys to have, okay? What can I do just looking at the system to help me solve the problem, right? Sure, you could always pull up Chegg or YouTube videos and like somebody will give you the solution, even just the book solutions. But nobody really explains what's the thought process to these kind of problems, okay? And that's what I want you guys to understand. There's a thought process that you need to have in your brain. So when the exam comes, you know exactly what to do because you're not going to have a solution for the exam, right? So just FYI, that is kind of my whole goal with these kind of videos. A lot of people don't do that, and I hate it. You know, I hated it as a student. But now I'm no longer a student. Now you guys are, so I'm hoping my method could kind of help you guys, okay? So now let's go to step 2. What I'm going to do is zoom in at point A, okay? The reason I want to do this is, again, I want to characterize this A into two components along this coordinate system. So that's exactly what I'm going to do. I like to start off by just drawing the actual component, A. So it's from this point to this point. And then I want to get it into this coordinate system because I know the plane got shifted by an angle phi. So initially your X was pink, Y was blue. Initially your coordinate system was like this. And it shifted an angle phi, right? You can see it right here. Look at the X, look at the pink one. It shifted phi, okay? But now look at the blue one. It shifted phi this way, right? So that's that angle phi right there that you just saw with my pencil. It was initially pointing up, then it shifted phi. So that angle's phi. Now what I'm going to do is, using this coordinate system, start from the tail of the vector to the end, using the y component and the x component. So I went y, x. I could have done this way and this way, but I already know this was my angle phi, so I decided to just stick it this way, okay? That was my thought process. The reason I want to do that is because I want to get an ax and ay in terms of a, okay? So just doing basic trigonometry, sine phi is equal to opposite over hypotenuse. That's what you get here. And then you get this, okay? Cosine phi is equal to ay over a. Boom. Solve for ay is equal to a cosine phi. I just, trigonometry, nothing crazy. I'm sure you can follow that. Then I'm going to do the same thing for w, okay? My bad, I'm a little sick. But again, I want to do it for A and W only because at the end of the day, I'm going to take a moment about this point. Now, what the book did, just FYI, what the book did, I mean, their method works too. At the end of the day, it's the same. You'll see it gives you the same answer, but they just took the moment about this point the way it was, but they did like, since this was L over 2, right? They did the cosine phi of that angle or something like that because this angle was phi. So they were able to get this distance all the way up to here, and they took a moment about that point. But I like to do my method. I don't like to change it. Maybe you guys do. Who knows, right? But this is my method. So same thing with W, right? Just draw W the way it is. Boom, from tail to head. And I'm going to use this coordinate system to get to my from tail to head. So I go along the x direction, which is this one. Boom. And this way. Doom. That's WY. Now, where's my angle phi in all this? Again, same thing. So initially it was like this. Look at W. I mean, it's the same logic that I use here, right? Everything just got rotated this way by an angle phi because you want it perpendicular to the board now, and that's that angle phi. Once you do the same thing that I did here, you'll see that this is the angle phi. And cool, now I'm able to get WX and WY, just like I did here for AX and AY. And boom, okay? So now this is my new free body diagram, okay? Right here. So now I don't care about the X component. Why? Because it goes through point B, okay? Now, I don't want you to think because I drew it up here that it's technically up here and it is going to make a point about a moment about point B because it's at a distance. No, that's not how it works. It's always pointing into the vector. This is just for illustration purposes. But if this is W, that means there's an X component pointing into the node, that dot that you see right there. The X component's pointing in and the Y component's pointing in, okay? That's what that means. So our X component is actually along this line right here, okay? And it's going through this point, so it's not going to cause a moment, so I don't care about it. Same with AX. AX is running along this direction, right? Because we determined it here, going into the node. And technically AY should have been here, but again, this was just for illustration purposes. But AY is pointing always into the node, AX is always pointing into the node. In this case, AX and WX go through this point, right? It's along the same axis, so it's not going to cause a moment. There's no distance, right? Force times distance equals moment. D is 0. So AY and WY, we're going to cause a moment. We know our distance is L over 2, so we could go ahead and just start taking a moment. Summation about point B, or whatever that point is, T, it's point B, my bad. So summation about point B is WY, right? This one right here. And it's going to make a counterclockwise, so it's positive. L over 2, your distance is L over 2. Then minus, because it's going to make a clockwise moment about point B, right, AY, minus AY times L, your entire distance. Doing that, you'll see the fees at the end go away, so that kind of tells you that this problem, the reason they didn't even give you fee, is because it's going to cancel out anyways. It doesn't matter what this angle fee is. You wouldn't need it in a real life scenario kind of thing. So that's kind of cool, right? Start looking at these problems from a design perspective. It's very interesting. I wish I did when I was in your guys' class, but I get it. You're just trying to get the A, no big deal. Now look, I was able to solve for A in terms of W, okay? Boom, so that's good. Because look, now what I'm going to do is I'm going to zoom in at B, okay? Now forget about this coordinate system. That was only to help me find A in terms of W. Okay, I'm done with that. Now let's go back to the original free body diagram, okay? So let's go here. I'm just going to take this off. Okay, so now we're going to zoom in at B, okay? If you zoom in at B, look, T has an X component and a Y component. Now we're focused on the global coordinate system. Forget about the system now, okay? T has an X, right? And positive Y, positive X. So it has an X and it has a Y. So does B. And that is your angle theta. That's where that comes in, okay? And you're able to see it here. Let me just do this. You're able to see it here. Look. This is where it gets a little tricky, okay? Now, you see a lot of angles. Forget about the fees if that confuses you for a second, because, look, theta goes from here to here. But, look, check it out. This is your coordinate system that we want, right? T, okay. T is along this linear path. You see that? That angle. So that means that T got shifted. So initially it was like this. Look at the red pencil. That's the dashed line that you see here, the red pencil, okay? You're going to go up an angle theta. So you're going to go up like this. This is the direction that T is in, okay? And that's what you're seeing here. Look, initially that dashed line that you see here. Let me use another pencil. Oh, this is an ugly pencil. But look, that dashed line that you see there, that was a red pencil. Then they got shifted up an angle, and now you're here at that T magnitude, okay? That was an angle theta. And it was the same thing here. Look at B. Well, B is just normal to T. Okay, so I mean, it's nothing. So if it's normal, right? So it's just if T was this way, well, that just means Y was in this direction. So look at B. Okay, now look at B for a second. Initially, your coordinate system was like this, and look how it ended up. Look at the blue pencil. That's your direction of B. Okay, so look at from here to here. Look at my blue pencil in my hand. From here to here, it shifted this way now. So that angle that is shifted, hopefully you can see it right, but that's that angle theta. That's that angle. Okay. So now that you have that, you're able to find your X and Y components. It's easy. focus on this theta. Well, tx is just t cosine theta, right? So it's cosine theta is equal to adjacent, which is tx over hypotenuse t. But then move t to the other side, you just get tx is equal to t cosine theta, okay? Same with ty, right? So sine theta is equal to opposite ty over hypotenuse t. So then solve for ty, you get ty is equal to t sine theta. Same with bx, okay? Bx, you get sine theta, right? Because this is the x component, right? So it's actually sine theta is equal to bx over b. So then b to the other side, b sine theta is equal to bx, okay? Then by, it's the up and down one, right? Y component. So you want b cosine theta. So it's cosine theta is equal to adjacent, which is by over hypotenuse b. Solve for by, you get b cosine theta, okay? Nothing crazy. Now that we have that, we could go ahead and do a summation of the forces in the x direction on the global system. Forget about this system now, remember? Now it's the global system. So in the x direction, this doesn't have an x direction. This doesn't have an x direction, it's just a y direction. T has a positive, right, x direction. That's just tx. What was tx? What was t cosine theta? So that's what we put here. Then b has a negative, and it's b, it's negative, right? And it was the x component, which is b right here, b sine theta. So it's t cosine theta minus b sine theta. Solve for b, or you could solve for t right now. I did b. I forgot what was the reason. It doesn't really matter. Point is, you kind of solve for both. B is equal to t cosine over sine, or t is equal to b sine over cosine. If you're new, you know, it's good to have just both, just in case you don't know which one you're going to use. But it's better to have both of them ready. But now we're going to do some of the forces in the y direction. So we know A, positive A, minus W, and then plus ty plus by. Okay, there you go. Okay, so it's A, remember, A minus W right here, plus t sine theta, which was just your ty, plus by, which is b cosine theta, okay? So now I already found A in terms of W, so boom, perfect. You see why that was helpful? So now I could just add these two together, okay? T sine theta stayed the same. For B, I just plugged it in. And you see, like I said, I could have solved for T in this case and had both of them in terms of B. But at the end of the day, you should be able to get both. No big deal. So this B, I did the substitution. So I got T cosine squared over sine theta. Okay, nothing crazy. I just multiplied that cosine theta to all this. Then that was a negative W over 2, right? Positive half minus 1 will give you a negative half. But if I move it to the other side, it's going to give me a positive half again. So it's W over 2. I factored out the T. I got sine theta plus cosine squared over sine theta. Okay? Well, if I multiply this to get the same common denominator, right? To have both of them over sine theta so I could add them, I'll get sine squared theta, right? Because multiply the bottom times sine theta, multiply the top by sine theta. Well, sine squared plus cosine squared, that's just 1. That's a trig identity. And that's a really important identity. You're going to use it forever, just FYI. Sine squared plus cosine squared is equal to 1. You'll always use it. So at the end of the day, you get 1 over sine theta. So just like that, I was able to find T, right? Just move sine theta this way. T is equal to W over 2 sine theta. Well, now plug in this T over here, and I'm able to find B. And there you go. Easy money. You found your magnitude of B, T. Yeah, they wasn't asking for B, but I mean, if you wanted to find it, go ahead, right? But that is how you do this problem. Easy, nothing crazy. I hope it helped. Let me know. All that good stuff you already know.